Hello everyone, and welcome back to the Fluctus channel. The revolutionary world of shipping has sailed a long way from robust steam propulsion to modern eco-friendly sail systems, like rotor sail and wind-assisted kite rigs. The industry, however, keeps striving for greater performance by continually improving on existing technological concepts of maritime vessel propulsion. In today's feature, let us explore a few modern propulsion systems that enable feasible marine navigation and could offer alternatives in moving the ships of tomorrow. Water bodies normally allow self-propelled vessels to float and glide on their surface, but modern technology has taken this correlation a step further. Water jets, or hydrojet boats, now use water as an alternative thrust force in their propulsion system, which connects an inboard engine to a jet pump. An impeller at the bottom of the vessel draws in and shoots a high-velocity stream of water from a nozzle behind to propel it forward. Water jet propulsion is one of the most high-speed propulsion techniques today due to the rapid acceleration and enhanced maneuverability it offers. Since the entire propelling system is contained within the boat, it allows for a shallow draft and prevents the boat from grounding. The sophistication of this propulsion unit is evolving rapidly with technological advancements. An Italian startup has developed a prototype of electric water jets, which are smaller in weight and size, and shaped like an aircraft engine pod. Since the motor and the jet are in the same device, the outboard installation creates an ideal cooling system, eliminates noise and vibration, and it takes up less space on board the craft. The prototype funnels water in the front end of the jet and accelerates as it passes through the smaller nozzle at the back. Nonetheless, the water jet technology is not feasible to all vessel types. The thrust generated by standard water jets can only provide adequate power to propel medium-sized watercraft. Larger ocean-going vessels would require the propulsion systems to be proportionately larger and more robust in order to help propel them. Additionally, the high purchasing and setup costs associated with this technology are still far too high to be integrated into commercial vessels. While the thrilling water jet technology helps propel watercrafts and smaller boats on the surface, another amazing marine propulsion system enables underwater divers to easily glide their way under the sea. A diver's propulsion vehicle, or a sea scooter, acts as a pulling force for divers to gently propel through the tranquil waters, making them exert less effort underwater. The diver holds the handlebars of the vehicle and turns the power switch on to take off. Usually installed with gear shifters, a motor, and a propeller, the sea scooter allows the diver to steer by moving the body in the turning direction. These diver propulsion vehicles may be used for recreational purposes or even for operations of the defense forces. The diver propulsion device, DPD model manufactured by STID Systems, is a popular and widely used equipment, even in the U.S. Navy.
We put it into production about 15 years ago in support of naval special warfare requirements in the U.S. So it met their spec, their range, all the requirements they had. And it became a huge success. So it went out of the U.S., worldwide, 500 units in operation, 30 different countries. So it's a two-man vehicle meant for infill, exfil of special operation units.
Just like the STID Systems, a German-based company named Rotenor designed and developed two military-grade diver propulsion vehicles, which are virtually silent and absolutely emission-free. They are specially designed, even, to be launched safely and accurately by paradrop, using helicopters or fixed-wing aircraft. Yet another sleek design of a sea scooter is the scuba jet, which has a cylindrical shape with a kite-shaped handle to ensure a seamless underwater ride. The scuba jet is operated using two silver buttons that turn on the motor and two black buttons on the side, which accelerate the gear. It also consists of a light on the cap of the cylinder and can also be operated with just one hand while underwater. A quite similar and competitive underwater propelling device to the scuba jet is the Janino S2, powered by two motors placed on the ends of the gear. The Janino S2 has a two-gear configuration, which allows the diver to cruise at a maximum speed of 2.7 miles per hour. It can also be operated using a smart app to control and monitor the speed, depth, battery life, and distance covered. Besides underwater divers, similar underwater propulsion systems are used by remotely operated vehicles, or ROVs. These submersible, robotic systems are generally used to reach the depths of large bodies of water by operators from a ship where the ROV is tethered during the duration of its deployment. For instance, deep trekker ROVs are used in the aquaculture sector to ensure that mooring lines, nets, and anchor points are secured to guarantee structural integrity. They are also used in search and rescue missions to provide a quick underwater response to locate sunken vessels and other items using its high-definition recording and other high-tech capabilities. Usually, underwater ROVs are used in conjunction with floating vessel operations to provide and deliver work and observation elements. Firstly, while on board, the winching system is load tested before connecting the vehicle for deployment. After which, a reinforced umbilical cable acts as the main tethering device and is connected to the ROV. Once attached, the ROV is gradually sunken at the desired place and depth of the sea. The tether provides both the electrical power for the ROV to operate and allows the transfer of data between the vessel and ROV to be transmitted. From high-speed navigation on water surfaces to the exploration of hidden depths below, the ever-advancing marine propulsion technology has steadily accompanied humanity in its quest for fast, easy, and safe expeditions. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.